Alright, in chapter 12, the first thing we're going to do in chapter 12, there's a lot of different ideas in chapter 12. One of the first things we're going to do is add and subtract matrices. Since you're going to find this to be really simple, I hope, if I keep your attention here, is we're also going to do scalar multiplication. So you can add or subtract matrices by adding or subtracting corresponding elements. Okay, it doesn't really make any sense until you see what it is. So this second part leads to a really good question. If we must add or subtract corresponding elements, what can we assume must be true of the matrices? So if I make a 1, 2, 3, 4, so we're going to make a 2 by 2, and let's say that I want to use addition, and let's just say that, so 4, 5, 6, 7, and let's make this negative 8, just to realize we can have negatives in here. So if they must be corresponding, this is a 2 by 2, then the second one must be a 2 by 2. And so they must be the same if we're going to do that. If I had a 2 by 2 and a 2 by 3, which means we have 2 columns, 3 rows, then at that point we would say no solution, can't do anything with it. But since they're both 2 by 2, we have addition in here, we can do that. So 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10. Notice how I'm going to stop in the middle and touch that sign. So 4 plus negative 8 is negative 4. So there we go. We have our scalar multiplication, or scalar addition of adding and subtracting matrices. So that's all we have to do. Alright, let's try out the next slide. So if I want to add these, so just a little practice. So if you want to, if you think you have the idea, then go ahead and try it and then look up and see if we have the same thing. So 1 plus 3 is 4. Notice my dimensions. That I have 2 rows and I have 3 columns. So this is a 2 by 3 and the other one is a 2 by 3. Negative 2 plus 9 is 7. 0 plus negative 3 is negative 3. 3 plus negative 9 is negative 6. Negative 5 plus 6 is 1. And 7 plus 12 is 19. So after our addition, this is our 2 by 3 matrices that we should get. Same idea when we subtract. Really not a big deal. Just make sure you stop into that negative sign. So 6 minus negative 4. Careful, minus negative means plus, so this should be 10. Notice these are both the first row, first column. So it's going to go in first row, first column. So negative 9 minus 3 is negative 12. 7 minus 0 is 7. Negative 2 minus 6 is negative 8. 1 minus 5 is negative 4, and 8 minus 10 is negative 2. So there's our final answer when we subtract, of course. So we're just going to do a little practice here, find the sum or difference. So here we are talking about the sum. So 2 plus negative 9 is negative 7. I think that 8 plus 6 is usually 14. 0 plus 6 is 6. Negative 12 plus negative 5 is negative 17. Okay, so that's my final 2 by 2 answer. Notice here I have 1, 2, 3. All right, these are rows. That's how you sit at the movies with your friends. You sit in rows. You don't sit one behind each other. These are columns. Okay, you sit in the same row. So if it is 3 rows by 2 columns, okay, and this one is the same as well. We do have a minus sign, so we want to be a little careful here. Negative 3 minus, so plus, so that's 0. I have 1 minus negative, so that's going to be 3. 4 minus 9, 4 minus 9 is negative 5. 8 minus 5 is 3. Negative 5 minus 4 is negative 9, and I have 4 minus negative 6, that's plus, that's 10. Okay, so 3 rows, 2 columns. Final answer there. Alright, now we can use this to solve, right? If I gave you x minus, let's say x minus 3 equals, let's say 5. How would you solve that? Right? Add 3 to both sides. So x equals 8. Okay, so we're going to use that idea and do the same thing here, except for instead of just having the number 3 that I have to add over, I have this whole matrix. So I'm actually going to do x equals, right, I'm going to add 4, 3, 1, 5, and add 4, 3, 1, 5 to both sides. So over here I have a negative 1 and a positive 1 for my matrices, so they're going to cancel each other out. So x is actually equal to 2 plus 4 is 6, 7 plus 3 is 10, 0 plus 1 is 1, and 6 plus 5 is 11. Okay, and of course I can check just the way I do anything else. I could start with this and say 6 minus 4 gives me 2, right? I'm using my answer. 6 minus 4 equals 2. 10 minus 3 equals 7. So we could go through and check the whole thing that way. So pretty neat. You're really doing a lot of new stuff, but recycling a lot of the old information that you know. All right. Okay, so in our next problem we have pretty much the same idea. Let's try out the green for a little while. X minus, so that means I need to add to both sides. 1, 1, 3, 2 is what we're going to add the matrix C. Alright, so we're saying that we did that to both sides, so this is just going to become x. So now it's all set up. So 0 plus 1 is 1, 1 plus 1 is 2, 8 plus 3 is 11, and we have 11 again. So that would be our final answer. Okay, so just like we did here. So we must add the matrix, so just trying to reinforce what we just talked about. So plus 5, so x would be equal to 30. We're doing the same thing, same process, except we're doing it to an entire matrix instead of just what looks a little more simple. What we have done. Alright, now evaluating matrices, we can use this for a nice cool little trick that if you want to find out what different x's and y's are, and maybe some z's. Now, if they say that our matrices are equal, that means the corresponding elements are equal. So I can find out what x is by setting 2x minus 5 equal to 25. So all I'm doing is taking this 25 and setting it equal to here. The other thing that we're going to do is I'm going to take 3y plus 12 and set it equal to y plus 18 once I get done with that. Okay, so let's go ahead and solve this one first. So I get plus 5, so 2x equals 30, so x equals divided by 2 divided by 2. Hopefully we got 15, so that straightens out what that first item is. So solve for x and y, so we have x. I'm going to find out what y is, so I get 3y plus 12, and that element is supposed to be the same as y plus 18. So we have variables on both sides now, so maybe get rid of this y, move that over. 2y plus 12 equals 18, so that's minus 12 minus 12. 2y equals 6, y equals divided by 2, we get 3. So I have x and y, that's all done. And of course I can always plug it back in, so 15 times 2 is 30, minus 5 is 25, and that does match my 25 here. So just like you solved anything else, we can check it that way. So we get a couple more here. So x plus 8 equals 38, so x equals 30, right? Minus 8 minus 8. So the big idea is just to set those equal to each other. And I can use negative y equals 4y minus 10. So if I subtract, I'm going to have negative 5y equals negative 10, and y equals 2. Okay, subtract 4y if you need to see that, and divide by negative 5. So we should get positive 2 there. Very good. Alright, we want to challenge you with these last couple here. So when we get done with the lesson, I want you to come back to this slide and check these out. Okay, down here I do have an extra challenge problem for you. Keep in mind that we can find out what x is right away, so you can substitute that back. Or if you really like your systems of equations, we can do x plus y equals 4 minus y equals negative 10. If you want to go that way, okay, that's your choice. Scalar multiplication, here we go. Not too bad. I'm going to take this number outside and distribute it to every element in the matrix. So 4 times 3, or 3 times 4 is 12. Go right there. So 3 times negative 1.5, negative. So 1.5, 1.5 is 3, so 4.5. 3 times 1 is 3, and 3 times negative 6 is negative 18. Done and done. I would make it more complicated for you, but I can't. It's just not possible. Scalar so 4 times everything in here, we got 24, we got negative 12, we got 0, we got 20. You betcha. That's it. Okay, so 14, 16. Alright, so 15, here we go. Negative 6, 2, negative 14, positive 4. You thought I was going to mess up, didn't you? Yeah. Alright, so positive 4. Alright, 0 times anything in here, so 0, 0, 0, 0. Okay, we want to make sure that we are writing our matrix, even if it's all zeros. Okay, it does have a solution. The solution is all zeros. Alright, so find the sum and difference. Can you do that? Okay, check that out. Find the product. Can you do that? Okay, we want to make sure we understand our vocabulary.